Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we'll solve another question from Leetcode. So let's get started. Yes. So today we have tagged as an easy question, but yeah, like obviously the way you will going to be solved, that on that perspective the question can be medium or even hard. So yes. So first try to understand the question. There is maximum value of an order triplet. 1. So what they have given, they have given a zero index integer and nums. Return the maximum value over all the triplets if of indices ij and k such that I, j, k should be follow these conditions. So you can choose indices I, j, k and what is the conditions among them? So all of them should be one after another. So I should come first, j then and k then, like this way. So you can choose any arbitrary 3 indexes called as triplets, and out of them this order should be followed. Now if all such triplets have a negative value, then we should return a 0. Now what is the operations they have performed? After that we can say it is a negative value. So that they have provided on the next line. So the value of the triplet of indices I, j and k is equals to nums of I minus nums of j into nums of k. So let's suppose your nums of I is smaller than your nums of j. So then on that case this negations is going to give you a negative value, and no matter with a negative value, and all the elements in our nums array is positive. So nums of k to is all cases nums of k is positive, and this factor, this negation factor can be negative. So if all the triplets are going to give you a negative values, then on that case they have asked to return a 0 on that case. How like all the cases you are not going to get any positive values. So let's go to our favorite OneNote. We can understand. Sure. So what we have at, so let's suppose what we have. So let's suppose we have a nums array. So I think the question is very straightforward, guys. I guess you guys are able to got the gist of the question, but if not, then let's just quickly do a quick iterations to our OneNote, and then obviously you guys will get the gist. Yes. So let's suppose we have an array. So that is our array, and on this array, so that is the partition of our array. So let's suppose that is our I. So let's suppose you choose your I point. This pain, man. Let's suppose our I pointer is at this index. How I can write? Leave it. So let's suppose that is our array, and let's suppose this is the ith index, and you choose this index as our jth index, and let's suppose this is our kth index, right? And let's suppose the array is monotonically increasing. So let's suppose it is 2, it is 5, right? It is 5, it is 7, it is 9, and it is, let's suppose, 12. Let's suppose it is 15, something like this. So your nums of I, what is the elements you choose as your I pointer? Via your I pointer, let's suppose you choose your I pointer here and your j pointer here. No matter any points you are going to choose your j pointer as the j side, as our right side is higher, So all the cases nums of I minus nums of j is always going to be negative. Your nums of I, right? Not sure why it is creating so much problem today. Minus nums of j. Only this portion is working. Okay, I guess my mobile also. Yes. So if on the arrangements the array is monotonically increasing, then on that case your nums of I minus nums of j is always going to give you a negative one, and all the elements are positive. So nums of k is always positive. So multiplication between a positive and negative is going to be give you a negative value. So if all the such cases we are going to get only negative value, sorry, then on that case you can return a 0 from that particular test case. So yes, guys, the question is as simple as that. And now for this, I guess the constant is very small. So if you can write a n cube solution, then also like 100 into 100 into 100. So that means 10 to the power 6 is also going to be fine, because we have a like 10 raised to the power 8 capacity in 1 second system can process. So yes, so you can write a very standard brute, and that is of obviously a big O of n cube. So yes, so this is something like this. I am not going to explain what it is, but you can see like we are starting our nums pointer at ith index, jth pointer as I plus 1 to nth index and k pointer is j plus 1 to nth index, and we are doing maximize of answer with this formulae they have given to us, and we have initialized our answer to 0, because if the test case that we just discussed, if all are monotonically increasing, then on that case, so here you also can see like it is a monotonically increase, so all the triplets are going to give you a negative value, so on that case your answer should be always store the maximum, so answer is initialized with 0 only, so you will provide a 0 for this particular test case. Yes, so now that is our NQ. I think it is quite brute. Now obviously your interviewer is going to be no matter, so it is dependent which company perspective the question has asked. So if you are like giving a very loose level companies interview, they are not focusing on DSA, then they just want to like see how you are going to, are you able to write the code, as simple as that. So but if such question is asked to a product based company, then get ready for yourself to the follow up question. So on the follow up, interviewer will definitely ask you, can you reduce the time complexity from n cube to something under n squared? Can you do that? Can you do that? So yes. So what actually we are looking for? So now your n squared solution from n cube to n squared, what actually you are looking for? So when you are standing to a particular index, so right. So when you are standing to a particular index, so let's suppose your these things, your this k pointer, we are lying at here. Let's suppose that is our k pointer. We are pointing at this particular index. Fine. If we are pointing to this particular index, so if we are pointing to this particular index, if somehow I know what is the difference, who of the all the elements to my left, to my kth left, what is the maximum value we can achieve? What is the maximum value of the triplet we can achieve? What is the maximum value of the, what is the maximum gap we can achieve? What is the maximum gap? Maybe my ith pointer, it is not work actually. So my pen is dead, bro. So let's suppose that is my array, and we have a liberty to choose our I and choose our j from this particular segment, because our k is landing at this particular index, right? So if I somehow know what all the values till smaller than my k, if I can store all the not triplet, all the pairs gap, so I will start a ith loop from 0 to n, we will run it, right? And we will start a jth loop, and I can start a jth loop from where? From obviously j should be my I plus 1, j should be my I plus 1 to n. So if I can, like this way, very initially I can store all the gaps. So maybe I can carry a frequency things, a dictionary, where I can store if I am standing at jth index, what is the maximum gap? What is the maximum gap we have encountered? What is the maximum gap we have encountered standing at d of j? So what all the I giving me the maximum gap of the jth index, with the jth index. So that is nothing but I can write a max function, and whatever the d of j is, I can do a maximizations of nums of I. The outer loop is going to be I only, and I will do a negation of nums of j. So after these iterations, my d of j, these things will store what is the maximum gap till this point with all of its leftmost I, with all of its whatever the leftmost I. So now I think we are quite good. So we know all the gaps. And now we can run a k loop. We will run our k loop. K should be start from where? At least where? 0, 1, 2. It should start from 2th index. And it will run till nth index, right? It will run till nth index, and for every index What is the possibility? What is the possibility? What is the possibility? What is the possibility? Like we can choose. We can choose. So now we can do we should run another loop which are less than my k, right? So give me 1 minute. What we have done here, so these portions, we do the very standard things. Like we have our default dict and we have put all nums of I and nums of j to d of j, and we have maximized our d of j to nums of I minus nums of j. That's exactly what I told. And now we are running a I loop from 1 to n, and inside, okay, sorry. So here what I am explaining, that is also fine, but you can do on this way, like you can set your ith pointer. That is going to be iterated for your dictionary value. That is going to ith pointer actually iterating to your dictionary value, and you are going your jth pointer to I plus 1. You can start your jth pointer to, so I is going to be start from 1 to n, so j at least. So rather than j, I can name it as a k. You can name it as a k. So that is your k pointer is going to start from I plus 1 to n, and you are going to maximize it. Maximize your answer to. So these are k. So this loop is iterating for k. This loop is iterating for your k. What is the maximum value? What is the maximum value you can find? What is the maximum value you can find? So on the right side, so when this loop is iterating, this loop is going for our dictionary, and for every dictionary value, so dictionary value is storing till this point what is the maximum gap. Till this point what is the maximum gap. So this dictionary d of j is storing that value. D of I is storing that value, and for this particular maximum value, what is the k? What is the maximum k? What is the maximum truth? So that we can get from this list. So standing at ith index, what is the maximum k we can get to my rightmost? So this is going to be assigned to mx, and finally we are maximize our answer to answer, and mx is our k pointer. We are multiplying it with d of I, right? So that is, I have to say, we are running 2 for loops now. One is for this to initialize our dictionary, and another one is like this for loops to calculating the answer. So that is of big O of n square, you can say, or big O of 2n square for sure. And the space complexity also associated for this particular solution, that is of big O of n. So that is, I have to say, better versions from brute. But if it is if interviewer are actually looking for the big O of n solution, or you are giving the interview of that level of company, then obviously interviewer is going to ask you, can you linearize your solution? Can you linearize your solution? Can you write a linear solutions for this particular problem? So then actually the challenge is going to be arise. So now I don't have to say it is a challenge, but there is a small I you have to put to your I, j and k pointer. So we will do the same things. Our k is always going to be constant. Our k is always going to our nums. And when we are, so let me go to the one note only. So we don't have any options. We can't do anything to our k loop. Our k loop is going to be iterated. For sure of big O of n. Going to be iterated for big O of n. So that is of 0 to, it's not working. So this is going to be iterated from 0 to n. That is for sure is going to be iterated. Your k loop is for sure going to be iterated from 0 to n. And so you have your factor nodes. You know your factor, right? That is the for loop. I think you guys are able to understand. So that is our for loop. This for loop is iterating from 0 to n. Now what actually we are looking for? For k, we are looking the maximum gap. We are looking for maximum gap. So can we start with a gap variable also? And initially we can assign it to 0. After that, for every such iterations, we are so initially we are going to maximize our answer. We are going to maximize our answer with max of answer to, what is the max of answer with till have at to what is the k value? That is, let's suppose that is our nums of k. That is our nums of k, right? Nums of k into gap. Gap means what is, because you guys are able to understand, right? Because gap we just pre-calculated. So So as we computing our gap later, so when we are landing at the kth index, we know our last maximized gap. We know our last maximized gap. We definitely know. So we can maximize our answer. So if we know maximize gap, and if we are at kth index, what is the left maximum gap? So that is exactly what we stored in the last solution, right? Big of n square, where we stored everything in a dictionary, right? What is the maximum gap? To my left, right? So that is going to be stored to our gap variable. Now after that, after processing this nums of k, should also we have to, after processing, not before processing, we also have to maximize our gap. We also have to maximize our gap to what? How you can maximize your gap? So current value is what? Current value is our each, that is of our nums, that is of each that you are going to iterate, that is your nums of k, to the high value. And what is the maximum gap? What is the maximum element still now we have found? So we want to put our ith pointer, which actually increasing your gap. Your gap is nothing but what? Your gap is nothing but your where your nums of I, where your nums of I basically standing. Your nums of I, where your nums of I basically standing. I know it's not writing anything, but let me write it. So where my nums of I is actually standing, where my nums of I, so my gap is nothing but where my nums of I is standing. Where is the maximum value of the I? Minus nums of j, right? Correct. So we need to maximize these things, maximize this factor. So how we can maximize? So what is the high? As big as nums of I we can determine, our gap is going to be more. So till left, what is the maximum value we have encountered? So let's suppose we have stored to a high variable, named as high, and we are also, like every iterations, we are maximize our high also with nums. We are doing maximize of high also with nums, and after that how you can calculate your gap? Gap is nothing but your max gap that you have at currently to what is the high value? Because we want our nums of I should be as big as possible, minus of your each. So that means till my each or till my k, what is the to its left, I am choosing what is the highest value, and I am doing the negations between them. So like that way we are going to get our maximum gap ready, and very next go, when our k pointer is moved to very next index, we are multiplying them. Like this way you are always going to get your answer to be on maximum set. So here actual trick is the order you are updating your answer, gap and high. So that is actually the trick. So here you can see that I have initialized everyone to 0, 0, 0, and after that I am maximize my answer, because I know my gap is obsoleted for the current index. I can't use that gap for the current index, because gap basically, what is the maximum gap? To my left, where my each is pointing, to its left, what is the maximum gap? I can't like make the gap maximize to the current index and then I am doing the multiplication. No. So gap means what is the maximum I minus j I have figured out to left of my k. So each is going to be iterated on kth index only. So that's the reason we are multiplying with each only. So what is the last iterations? What is the maximum gap we have found? We have multiplied with each nothing but nums of k, and after that, so now we have to update our gap. So to update our gap, what is the high value? We have at to its left. So that's the order. So we still not updated our high. So maybe my current elements is going to the maximum. So on that case, our gap is going to be, if so, high is also going to the maximum, and high is high minus each is also going to be high only. So your gap is going to be 0. But that is not correct, right? So your gap should be, what is the maximum high till its left you have it to my current elements. If that is also maximum, when it is going to be maximum? When my each is very small. So in that case my gap is going to be my very left, my gap is going to be very high considering that particular index. And after that, it's very straightforward. We are also updating our high because we will use that high value to the next calculation, and yeah, and finally we are returning our answer. So this, I have to say, is the most possible optimal solutions to this particular questions, which is working for sure of big of n. We are not using, we are doing a single pass only, right? And we are playing our entire games with three variables only. So on space perspective also it is of big of 1, but yeah, so let's clearly write that we do for every of our problems. So the time complexity for the most optimal solutions is big of n, exactly big of n, no big of 2n, 3n, nothing. That is of exactly big of n. And the space complexity for this particular question is also big of 1. We are not using any extra space. We are able to solve this with a constant space. So yes guys, so the question is as simple as that. And if you are solving it big of n cube and n squared also, I think it's quite simple. But the big of n, the order you have to update the variables, there is actually the trick basically attached to this particular question. The trick is only how you are going to update your answer and how you are going to make your other variables, gap, high, what else you are going to pick, but how you are basically updating them, the order you are updating them, that is actually the challenge for this particular question. Yeah, so that's it guys, that's it for this particular question and particular question solutions. That is the most optimal time and space complexity that I am able to find out, and I am pretty sure that is running off, I think 0 milliseconds. That is of 100% faster than all the submissions in the Leetcode we have it. So and you can also try to submit your own. And yes, that's it for today. And I know, and if you are able to understand till this point, you know what you have to do. You have to subscribe to our channel and please turn on the notifications so that when we are going to live to our next video, you will get the very earliest notifications for this particular. And please guys, please share the videos to your connections who are actually preparing for product-based companies and also brush up for their DSS skills. Please share the videos to your connections also, so that they also going to get most of that that you are also getting. So that's it guys, that's it for today. Bye guys, let's meet tomorrow with another beautiful question. Bye.